carry on with 4.4, page 61. I'm going to do quite a lot of these questions, you can see there. It says, question 6, in each part say which of the following relationships apply and find the constants of proportionality, in other words the K value. So I'm going to look at each one of these over 2 pages and try and link each one to one of these expressions or proportionalities up here, or these relationships, shall we say, rather than proportional. Well, they are proportionalities, they're relationships, because they're proportional to each other, whether directly or indirectly. Alright, so here we go. Let's look at A first and take it slowly. The diameter of a circle is x centimeters and the circumference of the circle is y centimeters. Okay, I know circumference equals pi times d, and my y is my circumference, so let's just link it, equals pi times, and the diameter is called the x. So look, I've got a direct proportion here, therefore what applies? Y is proportional to the x. See, y equals something times x, so y is directly proportional to x because circumference is directly proportional to diameter, and therefore my k value is pi. Alright, so that's my constant proportionality. As you know, pi does not change when we calculate circumference if we're given a diameter, or if we calculate a diameter given a circumference. Pi is fixed, so therefore A is done. B, the radius of a circle is x and the area of the circle is y. Okay, you know it's A equals pi r squared, don't you? You know it really well. And the area is y, so y equals pi times, and the radius is called x squared. Okay, fine, no problem. So do I have a y is directly proportional to x squared? Yes, I do. It's right there. Therefore it's y is directly proportional to x squared. The area is directly proportional to the radius squared of the circle, and my k value is once again pi, isn't it? Because that's not going to change at all. Just do one more on this page and turn over to the other 3. The price of bananas is x pence per kilogram. Alright, and the weight of bananas you can buy with £2 is y kilograms. So I've got kilograms with kilograms, I can't have pence with pence. So I think I'm going to take my 200 pennies, divide that by x, and I'm going to get y. Let's just study that. Here we go. The price of x bananas per kilogram, sorry, the price of bananas is so many pence per kilogram. So if I divide my 200 pennies by my x pennies, I should get the number of bananas that I can actually buy, or rather the weight of bananas that I can actually buy. So if I rearrange this thing here, I've got y equals 200 divided by x. So what have I got here? I've got y is proportional to 1 over x. Yes, I've got an inverse proportion here. So therefore I've got the situation y is inversely proportional to x, and my k value is going to be 200, because the £2 isn't going to change. Alright, because £2 buys me x kilograms of bananas, or 200 pence buys me x kilograms of bananas, and if I'm spending so many pence per kilogram, I can work out what weight that I actually buy. So that's it, k is 200. Right, next one, I'm going to do D here. The average speed of a car is x miles per hour, and the time taken to travel 250 miles is y hours. Okay, we know speed equals distance divided by time, and I'm told the speed is x. Okay, write down x here. So x equals, what's the distance? 250, and I'm dividing by time, and my time is of course y hours. So there I go, just rearrange that. I've got y equals 250 over x, and just by cross multiplying, y goes up, x comes down. So what do I got? I've got an inverse proportion again. So therefore I've got a situation where y is inversely proportional to x, and my k value is 250. Alright, so my constant proportionality is 250. That's a fixed distance. Next one, E. This one's tricky. The distance between 2 landmarks on a map of a scale of 1 to 50,000 is x. Okay, the actual distance between the landmarks is y. So right, if I take my x centimeters and I multiply that by 50,000, I'm going to get the real, I'm going to get the real distance for y. So I'm going to take my x, multiply that by 50,000 times. I'm going to get my answer in kilometers. Alright then, but that's in centimeters. So it's going to be y times, let's have a look. That's in kilometers. So how do I change these centimeters into kilometers? Okay then, let's just rearrange it first. Y equals 50,000 x's. So this is a direct proportion. So it's one of these again. So I've got y is directly proportional to x, and my k value is going to be 50,000. Alright, now it wants it in kilometers, so let's just take a look at that. That's in centimeters. I divide by 100 to get it into meters, and then divide it by 1,000 to get it into kilometers. So therefore k is in fact going to be 0.5 kilometers. Alright, or k is equals 0.5. Alright, and the last one, we're talking biscuits. The mass of each biscuit made at a factory is x grams, so grams, and the number of biscuits the factory can make from 10 kilograms of biscuit dough is y. Okay, fine. Right, I've got 10,000 grams. If I divide that by my number of biscuits, each weighing x grams, I'm going to make y amount of biscuits. Is that alright? Just rearrange it nicely, so, or rewrite it rather. So y equals 10,000 divided by x. So I can see I've got an inverse proportion here. Y is inversely proportional to the number I can buy, and my k value is going to be 10,000. Alright? I'll pause that and get back to you for the next question. I'm not going to do a separate video, it's just not necessary. Okay, resuming the vid, I'm looking at question 7 now. For each of these graphs, say whether it shows a direct proportion or an inverse proportion, or neither. Well, okay, fine, let's just do the obvious ones. Here, it's definitely a direct proportion. That's y and that's x, and we've got a direct proportion, so without any problems I'm going to say that one is directly proportional to that one. So y is directly proportional to x, passing through 0, 0 as well. Here, very clearly, I have y against x. If it's one of these inverse proportions, it has that characteristic shape. So that's definitely y is proportional to 1 over x, or inversely proportional to x. This looks like a direct proportion. It is, however, it doesn't start through 0, 0. Does not start through 0, 0. This will be something like y equals kx plus something. Alright, so it's obviously based on y equals mx plus c, but because it doesn't pass through the 0, 0 intercept, it is not a direct proportion per se, because it has to pass through the origin, as does the graph in C. So this is none of the above. This one is neither as well, because to have a direct proportion, as one quantity increases, so does the other by the same fixed amount, or same proportion rather. So that is neither, and this is just crazy. That's a neither as well. Alright, so the ones that are obvious are the direct proportions, y against x, the inverse proportion, y against x, and this one that looks like a direct one but isn't. So 3 neithers, and that's that, and that's that. Quite straightforward. This one took me ages to get my head around actually, and I disagree with the answer book totally. Now you can use your BMI to work out whether your weight is underweight, healthy, overweight, or really overweight, obese. It is worked out from your weight in kilograms and your height in meters using this formula. So your body mass index equals your weight divided by your height squared. And it wants me to sketch a graph. So that's my sketch, a graph of BMI, my body mass index, against my weight. Now I'm going to assume, they say assume the weight is the height is constant. So let's just say, for example, I have the formula BMI equals weight divided by, let's say I'm 1.5 meters tall, and I'm going to square it now. So my BMI is going to be 1.5 squared, and I'm going to inverse that, so it's going to be inverse that, reciprocal that. So if I work this out, it's actually 0.4 recurring W. Now, let me just pause that because the book has just fallen on the floor. The book is no longer on the floor. Adjust the camera just a bit. Alright, so look at this. If I'm plotting BMI against W, and this 0.4 recurring is constant, I should see a linear relationship between BMI and W. It follows the pattern y equals mx plus c. Well, my c is clearly 0, 0, 0, because there's nothing after the w, and my gradient is 0.4 recurring. So I'm going to stick to the answer straight line relationship, and that's that. And the answer book says something really crazy and different, so I think they're way wrong. Next one, sketch a graph of BMI against height. Okay, so I'm going to go BMI, capital, against my height. Now, what's happening here? Now, if you look at this again, I've got BMI equals constant weight divided by my height squared. I've got essentially a 1 over x squared type graph. Do you see? Which looks the same as a 1 over x type graph, except that the curved effect, the curved effect of the 1 over x squared graph is more pronounced than the 1 over x graph. So essentially, since I'm doing a sketch, I'd expect something like that to occur. Alright? Think of it logically. If my weight is staying the same and I'm getting taller and taller, then my BMI will drop very quickly. If my weight is staying the same and my height is really small, my BMI will be really, really big. Now look, it's going to follow that pattern because we're based on h squared and not a straight h. Even if it was a straight h, it would still give this pattern anyway. Alright, so that is the graph of body mass index against height, following that characteristic pattern, the 1 over x or 1 over x squared type pattern. And this one is just a direct linear relationship because the height is constant. Alright, so that's my story and I'm sticking to it. And I think I'll stop there because on the other page we're into the assess and then we're end of part 4. Okay?